So first of all, thank you for having me as part of this brilliant agenda for today. You've probably got a flavour for some of what I'm going to talk about from the scene behind me when my camera was up, and I'm not the first person to talk about Lego, but I'm talking about learning through play. So a little bit about the context that I'm working in. I'm a module leader at the School of Engineering in Lincoln on 2 first-year modules, one in computing and programming for engineers and one looking at mechanics. And I'm looking for ways to make those modules more engaging and also try and link them together if I can. I also look after the teaching and learning for the wider school as well. And most importantly, of all those letters we might put after our names, I think AFOL, Adult Fan of Lego, is pretty important for me and will come in here. Some of the themes for this talk came from one of the previous webinar series that I joined back in June from Kent, which was looking at learning without borders. And there was a question posed. If we teach someone, and I think the question actually was talking about maths, but if we teach someone maths, and they learn the maths but totally switched off by the process of learning, so they come to hate the maths, is it really worth it? And it sent me away thinking, well, what do I do to actually motivate and engage my students? So the product of that thought process is what I've put together. Some of it I've tried already and some of it will be new for me for this year to try out. So I thought about where do I what do I try and do in my teaching sessions? What are the core bits of the fundamentals that I do? Ask questions, pose problems, and then get students to actually carry out some kind of activities. And I thought, where can I draw inspiration from in the everyday world? What inspires and engages people generally? Sat there writing this quite late at night in front of a television. I thought, well, TV programs, they're quite engaging. So I had a look down the list of what's on TV at 9 o'clock at night. Reality shows and quiz shows came up quite heavily. Short of marrying off 2 first-year students and seeing how they journeyed through their first year, if they did any better, that's probably a fairly niche thing that most people can't do. So I thought I'd focus on the quiz show element and the question styles, how we pose questions to our students. Another thing that inspired me quite a lot is some of the video games that students come in and talk about in my teaching sessions, and whether I could link that to some of the conversations. And then being a relatively new father, thinking about some of the playful aspects that children have and how we can develop that to being more educational at a higher level. So some of the sources of inspiration, the quiz show element, there's all sorts of quiz shows out there, and they've all got different styles of question that we can borrow from and that we can apply in lots of different subjects. I'm going to show some engineering examples, but they apply across many subjects, and they work whether we're teaching physically on campus or online or in some space that's a hybrid between the two. And the other source of inspiration, Clara and Gwen. Clara, who quite enjoyed putting together some of the models that you'll see later on in this presentation. So some of the examples of quiz show type activity, things like what happens next. So you just throw up a picture, what happens next? And this is one of my computing slides, and students have to go away and effectively what I'm asking them to do is code a set of LEDs to come on in the sequence of the traffic lights. So it's a fairly early computing question. It inspires a bit of creativity when they answer. Some of them talk about the car because they recognise the car from the Lego set. Some of them, lots of them, say what happens next, the light goes green, and you have to say, does it? Is that the sequence of a set of traffic lights? But it's a bit more interesting than some of the more traditional ways that you might just type the question on the screen. Another example of a game show inspired round, the odd one out, from something like Have I Got News For You, engages discussion between the students because they have to not just pick which is the odd one out, but then explain why it's the odd one out. And I've deliberately put 2 possible answers there because there's always some students that will say, well, it's the bottom right one because the bottom right one's the only one that's a toy and all the others are real world objects. but actually there's a more engineering focused answer as well, and we're trying to get the engineering bit across in the mechanics lecture. But again, more engaging perhaps than a traditional way of asking the question that fewer students seem to engage with. If anyone's a fan of Only Connect, they have a round where you think about sequences and putting things into sequences. We often think about stages in solving a problem, stages in a process. But do we actually get the students to think about those stages, or do we just throw them into a practice question and get them to try and work it through as best they can? So this is maybe the start of a lecture after I've told them how to do it, I've explained it, they've maybe done some pre-reading on it, they come in and then they try and put the things in the right order. It's quite a quick piece before they go into the actual answering of a question. So it might lead into something more traditional, but it's just getting them to think through the process and slow down a little bit before they go into the actual answering of the question, which might look something like that. One of my favourites that I've not used yet fully, but I've started using, and this particular example I'll use this year, is how much. So it's if you can picture Bruce Forsyth on the supermarket one, where you have to work out how much a tin of beans is worth, and you can be as much as £1 under but not 1 penny over. That's the sort of challenge that I'm setting the students for this particular lab exercise. We used to have 10-page booklet, and they had to work through the method and take some readings and come out with some graphs and analyse and evaluate like you would in a fairly standard lab exercise. For this, just by setting it as a challenge, and the only rule being that they can't put the 2.5 Newton load on the hook to actually test it out until they've got a full answer, is they have to develop the methodology. They're working in small groups, but they have to develop the methodology themselves. They're competitive between the different groups, and because you're doing this in small lab groups, you then have like a leaderboard that carries on through the week, and they're looking at how the other groups did, and you only release the answer, the final answer to the question, at the end of the week. So there's an element of competitiveness there. I've not done it with this exercise before, but I've done it with similar exercises, and you get more engagement during the lab session rather than just seeing the final write up at the end, and more questions, more conversations going on in the actual room as you stood watching them. This is the answer. What's the question? So that's Mock the Week, I think, uses that round of questions. So something really quick to start students off. Throw up answers and ask them, what question could I be asking? There might be more than one answer. Some of them are very quick. You could share them in pairs. Some of them take a bit more calculation. So something like PIN, what's the question they might be asking? They might say, what sort of joint is joint A? When you get to something like a calculation question, they might have to sit there and be a little bit more thought going into it before they start to answer and offer answers. But everyone's taking part either as an individual or in pairs before they come together as a class. Asking questions like that, rather than just throwing a bigger question on the board and getting them to work through it straight off, seems to be getting them to think about some of the smaller steps in the process before they start to then go into the bigger tutorial practice questions. For my bluff, or probably more appropriately, would I lie to you now? That's probably a bit more familiar to students. Posting a statement underneath a diagram, for instance, and asking students, is it true or is it a lie? But also getting them to engage and say why they've thought that, or why it's not true if they know what the true statement should be. And the only caveat with that one is if you're doing a presentation, you're sharing the slides before the session, or I'd hide the answer slide, but I'd definitely include an answer slide so that when they're looking back, they don't learn mistakes because you haven't said it's a lie if it's a lie you've included. But again, it's a bit more engaging than perhaps describe what rules you'd use for a zero force member. And then one of my favourites, the observation round. We all had that photo at the start. What's changed? Well, we've got a small yellow box with a black button on it, so it's meant to be a pedestrian crossing. Students then need to go away and make it work rather than just as a sequence of traffic lights with a pedestrian crossing. There's an extra input in there, but again, it's an extra it starts the conversation, you know, what could be different, what's it meant to be doing, how does that work, rather than just saying go and design a pedestrian crossing, a button that changes the steps in the circuit. The second area that I looked at was, I thought, how do I pose problems? What context do I set my questions in? And really, I'm teaching first-year students that come from a whole host of different backgrounds. So mechanical students, electrical students, biomedical engineering students, and mechatronics students. So from week one, they've probably got very different understandings of engineering and backgrounds of study. So I've thrown in the context of a Lego city, different examples that they can pull out of engineering in that image. I'll run through a few. So we've got things like the coding and the traffic lights that we've talked about previously. We've got things like loading pallets onto a lorry, thinking about how the centroids, the geometric centre of gravity, where that would be placed. You've got a cannon there, so you can think about firing projectiles. And then with workmen and construction, I'm afraid my dining table wasn't big enough, but you can think about cranes and all sorts of forces and movements in that context as well, if you've got a crane in there. And then finally, the final Lego scenario, my dining room table definitely isn't big enough for the train set as well as the rest of the city. But getting students to automate a train set. Now, Lego have some wonderful train sets, but not necessarily ones that you can automate yourself with computing and control. So the example here you can see is all bespoke. Students can program it with, it's running off a TV remote, but it's got the concepts of the computing module they've just been learning. They can build onto it, and then they can pitch their system, and that can be part of their assessment at the end of the module. And students seem to engage with that, where they've got something they can get hands-on with, a lot more than they do with just a theoretical piece where they're writing a code on the screen. For the mechanics module, I've then taken the context of a computer game. It looks like that's going really slowly on my screen, at least, so you're just going to have to take my word that it's one of the best times I've ever done on that level. But how does Sonic get from the start to the end of the level? Can we describe it with equations? If it were an ice planet, what would the differences in terms of friction be? Can we find examples of different sorts of motion in there? Can you get students to design their own level with engineering mechanics rules built into it?
Just 1 minute left, please, Alex.
Sorry, say again? Just
1 minute left. Sorry, Alex.
Yeah, no problem. And then the question I always get asked, is it just play? No, it's not just play. It's using the things that students are familiar with, drawing inspiration from things that engage in the everyday, but also making it relevant. And the next project you can see, I'm trying to redevelop an old Lego set on screen that will draw together the computing and the mechanics to seal in some of those fundamental ideas that are really engaging them at the moment. And I will leave it there, but I have got a short QR code just for any feedback that people might want to share, and I'll post a link in the chat.
That was wonderful. Thank you. We could have done with a lot more of that, I'm sure. We should end in the spirit in which you talked, though. Alex, you passed on just one. That was the quiz show with Bruce Forsyth, and that was The Price is Right. Thanks to Samuel Dilley for filling the setting in with that. You've reassured a lot of people that what they're doing is absolutely the sort of thing they should be doing, and inspired a lot of people, I'm sure. That was absolutely great. Thank you.